Oh, I see. With this group, Hansen filter equals a lens cap. Got it. So we're good to go, or? Oh, look, wow. So it's not, it's a red light on one or the other. All right, well, let me call this august group. Let me try calling the august group to order. I need a gavel.
There's audio.
There we go. There we go. All right, so we have, I think, truly an amazing panel because these are the top CTOs from across the spectrum, ranging from low-level network equipment to high-level SaaS services and everything in between. So maybe the best way for me to start off the panel is to build some credibility by having everyone do a short introduction of themselves and cover all the important stats like prior editor-in-chief duties and or OpenStack chairman duties and things like that.
Okay, I'll get started. I'm Doug Junkins. I'm the CTO for NTT America, and if you're not familiar with NTT America, we're the U.S. subsidiary of NTT Communications, the Nippon Telegraph and Telephone. My duties actually include a wide range of different interests, from our network services to our data center services, and ways that we can actually leverage all of our product portfolio better to tie them together for our customers. So that's kind of my
and that product
purpose
portfolio
here. Spans private networking services, global IP backbone, and data center services business. So mostly infrastructure as a service from the network and data center perspective.
Including dimension data and OpSource and all that. So
correct.
You have cloud cred. Okay, next.
Hi, I'm Peter Coffey. I'm head of platform research and CTO for automotive industry initiatives at Salesforce.com. I've been with that company for almost 6 years. I joined the company because Mark Benioff said that a conversation we'd had 3 years earlier about becoming a platform as a service provider was about to turn into an actual go-to-market with that positioning. And in the 6 years since then, something on the order of 250,000 applications have been built and provisioned by our customers on that platform. Our stock ticker symbol is still CRM, and we still do CRM. But we are now trying to extend that label far beyond the usual model of people inside the wall talking about customers outside the wall and making it instead an active process of listening, adapting, including customers in that conversation, and our recent acquisitions in areas like network sentiment analysis and media placement and analysis are all part of that proposition.
And what you do before Salesforce?
I'm sorry. In past lives, I was in big oil, big space, and big computer industry journalism when the last was not an oxymoron. I have been on one ANSI committee for the standardization of the Common Lisp language. I've written one book on Java. And have been involved in a number of things that I can't talk about.
Got it.
Right.
Good. Lou.
Hi there. I'm Lou Tucker, CTO Cloud Computing at Cisco Systems. I'm responsible for driving our overall strategy as Cisco is moving much more into the cloud itself. In terms of past history, actually, I was at Salesforce.com back in 2004 and was largely responsible for building out of that platform in terms of the app exchange and other things. Before that, 2 tours of duty actually at Sun Microsystems, part of the early Java team. We really saw the explosion of the internet and applications starting to appear on the internet. And way long ago, high-performance computing, comes called thinking machines. So distributed computing and platforms and everything else has always been where my head's at.
And do you have any hobbies with OpenStack?
Yeah, I'm also a vice chairman of the OpenStack Foundation. I've been bringing Cisco into OpenStack, and I'm sure we'll touch upon that later.
Hi, I'm Jack Waters. I'm the technology officer for Level 3 Communications. I've been at the company for 15 years. I joined the company a little bit prior to its founding and have seen it grow a little bit over the last 15 years or so. Today we have about 11,000 people, and we operate in 3 major regions around the world. Our responsibilities for all the technology and development for the company. And I've done a number of things, run operations, and had a little side project last year integrating Global Crossing and a few other little things.
Steve?
And I'm Steve West, CTO of a 6-year-old company based in Petaluma, California called Cyan. We're an innovative next generation company that looks at the overall technology picture for the way networks evolve, particularly the optical and packet layers, but most importantly, the software implications of how the changes in those technologies are impacting everything. Our market focus has been the US, and we've since expanded into Europe, and now we're making great strides in Asia. The bottom line here is that everything is changing on the technology front, and we as a company are trying to really identify those trends and make sure that we're able to help our customers take advantage of things like 100 gig and DWDM, WSS, SDN, and so on. Prior to the Cyan opportunity, I spent about a year before we actually started the company, prior to the founding. But before that, I was with Turin Networks, and prior to that, Advanced Fiber Communications. All companies that were started in the Northern California area, small town, Petaluma, where a lot of good things happen. So thank you.
So maybe I'll start from this end, since you mentioned some things. It's the CTO panel, so the obvious question is, what technologies are you all looking at? Is it SDN, quantum entanglement, or what? So
and given that we have production next year.
Yeah, exactly. So let's maybe just go ahead and start with you, Steve. And what's really of interest? What do you see as disruptive? What do you see as something to either be concerned about or to exploit?
Well, I think the bottom line is that we're all familiar that bandwidth is a hugely important dimension of anything we do at any level. So anything that impacts bandwidth is something which we as a company focus a tremendous amount of attention on. And I think there are two important dimensions. The one is just pure capacity, getting the capacity to where it's needed at the right price points. And I think for all of us in this room, this impacts a lot. The idea that we can get 100 gig transmission into the metro within the next couple of years, I think is going to really make a big impact. The other thing I think is that clearly, even though we have the capacity, we've got to actually be able to deploy it, and that's where Ethernet comes in. And Ethernet's, I think, universally established as the interface of choice moving forward. It doesn't matter if you're talking about wireless backhaul or inside the data center, Ethernet's part of this. And then I think the third area that's most important is software, because what you have to do is coordinate at unprecedented scale over unprecedented scope. We have a heterogeneous environment. It's not that old one-size-fits-all environment we've had over the last several years. And I think those are the three areas that are of great interest to us. We obviously understand that the old technologies will live on, but for example, SDH and SANT are important technologies. But as we move forward, they're going to be just too expensive. So we have to assist our customers to transition to more cost-effective solutions. So I think that's really the focus of our technology endeavors, those three items.
Jack?
We have a number of areas we look at. We tend to be pretty focused always on the underlying economics of technology, because we spend $800 million a year buying stuff. And I think right now we are at a pretty interesting point in technology, given that things like 100 gig actually are starting to make economic sense to folks like us. Whereas before, a little bit tougher equations, the supply chain wasn't developed the way that we would have liked. There aren't enough buyers. The data center folks are starting to help the telecom folks in their supply chain. So that's a really great convergence of technology. And we're starting to see, all that said, is that the crossover for 10 by 10 versus 100 is going to happen. If not, maybe has already happened. It will happen within the next 4 quarters. I usually don't speak in such absolutes, but I'm almost 100% guaranteed that that's going to happen to the supply chain. And that's going to be a really interesting time for us all. The other area of technology that we're interested in, but probably think is a little overhyped right now is SDN. We think everybody gets it. It's a really great idea. It's actually a really old idea that for folks that have been around for a couple decades will remember. I mean, the idea of centralization and then distributing decisions out into a switching platform is not the most revolutionary of new ideas. It does so happen to be at a time where those platforms are starting to disaggregate themselves and become a little less special when you look at the underlying how they actually work, and there's a better place to get the components, and so I think that's going to be an interesting jump-off point for us too.
Lou?
Obviously, since I'm CTO cloud computing, I think that cloud computing is perhaps the most interesting disruption or re-articulation, actually, of what we have been trying to do in the internet for many, many years. And one way that I try to think about these disruptions, the CTOs were always expected to look around the corner and all of these kinds of things, but is in terms of the value chain, and particularly being at this conference and looking at, that you have, the carriers, you've got the wholesalers, and now we can start to look at this industry much more in terms of a value chain. And I think that the notion of software-defined networking and everything else is really an expression of, at the end of the day, we've got to deliver some application or service to an end user with a great experience. And in order to do that, it probably requires a lot more coordination between the layers than we've ever seen before. No longer can you statically provision or over-provision bandwidth and expect it all to work at a cost point that the end user is willing to pay. So now I think that between cloud computing and the platforms, we're really looking to create that kind of conversation between the layers. In many ways, I think that the networks, we can talk about, Cisco has talked about intelligent networking. And what that really means is that instead of the network it actually has had a very long-lived distributed, protocols and everything else to make it all work, and we should be all very proud of that. But it wasn't listening. And so the big thing we're trying to do is get all the way back from that endpoint device or the tablet or whatever and broadcast that information back through all of the different layers and the different companies involved so that we really can have a much better experience in the end for the user.
Jim, I think the most interesting and well-visualized future that I've seen wasn't portrayed by Apple or us, but by Corning Glass in a pair of videos they did called A Day Made of Glass, where they were talking about architectural display and interactive devices that pretty much infuse your entire environment, where pretty much any surface you can touch is capable of delivering information or mediating function. And a couple of interesting things happen in that environment. Number one, if you're going to be interacting with things on multiple devices, none of them can be the repository of state the way your laptop hard drive all too often is. You're going to have devices that don't need state to know everything else you've been doing and everything else other people have been doing. That implies a cloud. At that point, you're not evangelizing the cloud. You're just saying, look, you're going to have a cloud before this environment's going to make any sense to you at all. The other thing that's happening is a tremendous loss of the asymmetry of communication power that has made big companies able to dictate their marketing messages. At this point, thanks to 140-character press conferences called tweets, the individual customer now has just as much power to reach a global audience in an instant as a well-crafted and very expensive media campaign used to be needed to achieve. And so when we talk to our customers, they understand that there will be bandwidth. They understand that there will be portable devices. What they want to know is, how does this affect the way they do business? And I tell people there are three traditional advantages of the big company: location, people who are far away from you were less available. If you had competitors who were on the other side of the planet, they didn't matter. Well, now they do. Communication, it used to be, if you had a multi-million-dollar Mad Men budget, you could control the conversation around your brand. Now you can't. And capitalization. It used to be if you had massive investments in IT and communication, you had a barrier to entry against competitors, and now you don't. So those three traditional protections of the incumbent are gone, and that means that new players see opportunity that otherwise they might not have, and established incumbents see threats that in the past they might have been able to ignore. So all these things are catalyzed by technology, but to take Jack's point about not making absolute predictions about the future, when a big rock is at the top of a tall hill and it starts to roll, it's not really a high-risk prediction to say that anything between it and the bottom of the hill is going to get rolled over. That's really not making a prediction. That's pretty much just stating a fact that's yet to be realized. And that's really where we are. These devices are out there. The bandwidth is out there. the expectation that people have for social interaction and the ability to communicate is there. These are not pendulums that will swing back in the other direction.
Well, I want to come back to you because one of the big themes certainly of Salesforce has been the democratization of IT in the sense of it's not the domain of the IT department anymore. It's the option for a, quote unquote, lowly clerk to be able to leverage platform services.
Or a lowly business unit VP to be able to tell IT, I'm not going to wait for you to approve this.
Lowly on the inverted pyramid,
so,
exactly.
So all of these things are catalyzed by technologies that everybody here is involved in executing and delivering. But what galvanizes your customer's interest is, how is this going to change all the rules, and how do I use what you have to make sure I'm on the right side of future history?
Right. Okay, Doug?
So I'm not
What
sure
are you
I
tracking?
have the same crystal ball that Peter does, but
Well, that's what makes it interesting.
what I'm really looking at right now in the industry is looking at the ways that cloud has revolutionized compute resources and looking to see how we can leverage that on our other services like network infrastructure to bring more customer self-service that people have come to expect from cloud computing, API interaction with network services so customers can have much more direct control of the services that they're offering rather than having to open trouble tickets to change something. So really looking at ways that we can provide that programmatic interface to all of the services that we're offering to make the customer experience much easier for them to utilize our network services and our compute services together and really create global infrastructure that they can manage themselves.
So I'm going to tie that whole notion of sort of network programmability and APIs in a second, but I couldn't help but think that there's the opportunity for some tweet-length answers to coolest technology you've heard about in the last 3 months or even past week. And for me, the answer actually is yesterday, Todd Bundy and Christian Ilmer from Adva were talking about the optically aware OpenFlow extensions. So that was cool, and I hadn't heard of that. So any quick tweet length, even phrase length, like from anyone? Just amazing new technology?
I did a tweet on it.
Oh, okay, well, there you go. I already used that one, though, so you can't use it.
Vibrating fork at CES.
I was at
I didn't
CES,
see
and the
that.
coolest thing I saw at CES was a little network adapter that combined some Qualcomm stuff and some Wilosity silicon to do 802.11ac and D, which means 7 gigabit per second wireless in an in-room network. And
That's
this
great.
is, I mean, gigabits per second.
Right. Think about how much information your light bulb can now send to the home residential.
And
grid.
when you replace incandescent light bulbs with LEDs, that actually does become a communication channel.
I know.
Yeah,
I
exactly.
saw the TED
Right.
Talk. Yeah. Okay. Anything else?
I'm sorry.
Cool tech?
I was kidding about the fork. I'm.
They did have a fork at CES, though. They
Yes, they
measured
did.
your
They
calories.
made a lot of
That's-
lists.
yeah.
I think that we're sort of witnessing something that when we started our company 15 years ago, there was a big argument whether you'd ever be able to carry a phone call over IP technology. It's laughable. It's laughable that we even had, there were standards committees that said, oh, you have to do it this way, you can't do it this way. And today, we are watching the way video is consumed, transformed in front of us. And there isn't even the argument, can you carry a video transmission over an IP network or over any network? That's sort of gone by the wayside. In fact, all the hoopla is around who owns the rights and what's going to happen to all the advertising and all the very non-technical sets of issues. But when you step back, I continue to be amazed at the quality and depth of information you're able to watch on pick your device, tablet, home TV, whatever, and the quality at which you're able to view video today. And I think we are at its infancy. It's if you want to see the numbers, go look at Mary Meeker's industry trends deck. It's a fabulous piece of work, and we are at the very early beginning of what that's going to mean to our industry and what it's going to do to cable and all those.
So Steve, you were going to jump in.
Yeah, I think what interests me is technology changes that have profound, disruptive economic impact. And just last week, I had one of those kind of items come just in your face, and it was an Intel announcement of their planar light wave circuit-based transponders for inside the data center. What I believe is that this is an essential technology. If we're going to take advantage of Moore's law, we've got to move up to much higher bandwidths on the I/O ports of our chips. This is an economic requirement, because otherwise all the advantages of Moore's law get discounted by the complexity of the I/O ring around the chip. Mm-hmm. So the ability to move to cheap photonics within the data center is a profound and critical change. Now, what that does is, in my view, it changes the economics of so much of everything we do on this panel. First of all, it's going to enable microservers. Microservers will change the economics of the data center, in my view, quite profoundly, because the densities go up and the power consumption goes down. What that does is it enables a whole wave of software innovation that, in my view, will impact the whole layer cake. Everything's going to be affected by that. And obviously, Salesforce has been leading the charge on some of these software concepts. And how that impacts me in my role is the view that that data center model impacts how we run our businesses, including how we run networks. It's not just that we provide the links so that those good things can work. It's that we can use those good things to make the network work. So I think if you couple that value chain, I think we're going to have a fantastic resources. When we blow those constraints away, we can start to model the interaction between a lot more things. And that allows us then to have software that understands that interaction. And just to give a trivial example, if we can, within one database system, enabled by these new cloud computing-based approaches, in one computing system model everything in the network, from the physical layer all the way up to the applications, we can now have software that understands those interactions and makes actually the automation of those networks a lot more cost-effective, which then extends that capability out to a much larger audience.
So speaking of automation of the networks, to me, the most important thing that relates to our industry is the convergence of IT with networking. And so, Lou, I'd love to have you expound for a few minutes on what's going on, both specifically at OpenStack with quantum and everything else, but the broader network as a service concept and the way you conceive it.
One of the things that was recognized about a year and a half ago when OpenStack is a response by the open source community to build a platform, a software platform that anybody can build their own private public clouds. And one of the things when we started formulating that was looking at the existing models, Amazon and Eucalyptus and others, and really recognizing cloud computing has really been focused on computing alone. And as storage has become that more important, so it's really been the model of Amazon's EC2 and S3 computing and storage, and networking was just connectivity. We really recognized when looking at OpenStack that we needed something more than that. Computing really is, computing, storage, and networking. And so we undertook this journey to say, what do we want as a network as a service? What is the language of the applications that they want to express at a certain topology? Please don't make my backend database routable from the internet. I would like to open up a connection that's going to be used for streaming media. Those are in application terms. And what we decided was this project called Quantum, which is alongside of the computing and the storage service, so that we can express that conversation and translate those requirements down into the lower layers. And then lo and behold, SDN is coming along saying, and now we have a programmatic way of managing the networking infrastructure. And those things go very well together so that we can really start to have that kind of expression of what an application needs. And I want to hark back actually to Mark Benioff and the success with Salesforce. One of the things he was always making a point about was multi-tenancy and self-service. And those are themes that have continued in terms of we want the application to be able to express what it wants. The app at a moment in time can't file a trouble ticket and say, please, I need to have more resources allocated to this. It has to be done through APIs. So software is becoming critically important now throughout the entire value chain so that we can make that kind of connection and respond to what the users are needing.
What it does is replace traditional von Neumann computation, which always had serial bottlenecks and I/O bottlenecks, with a much more inherently distributed model that's based on pattern recognition. Someone at an MIT conference in San Francisco earlier this week said, too many people think big data means a big database. Yeah. What it means in many cases is being able to replace the question, what is about to happen with, given the last time these 100 things looked like this in this combination, what did happen? It's a data-oriented, pattern-oriented approach instead of a computationally oriented, algorithm-oriented approach. And doing algorithms better, faster, cheaper will continually bump up against these bottlenecks while moving to a different model in which networks clearly play an enormous enabling role is actually how you evade and dissolve that kind of bottleneck.
So I have a question for you though, since you're at Salesforce and you run platform research. Is the stuff that Lou and OpenStack are working on as far as quantum, is that something, I don't know if you can announce things or not, but I mean, is that something that is relevant to you, or do you see yourself as we're over the top and I don't really need these fine-grained network controls?
They run rather large data centers.
Well, I like my job, and that's why I'm not going to make any predictions.
For a platform as a service provider that exposes various
the beauty of our
things through an
approach
API.
and the fact that it is multi-tenant means that our customers don't really see anything that tells them how we're running it behind the wall of the APIs. They see metadata and APIs. They don't see the hardware. So we moved from big Sunfire servers to commodity x86 boxes because that was the appropriate cost effectiveness point. At some point, that underlying platform will evolve to whatever comes next. There's no reason why that should be disruptive to our customers. I mean,
so if I can, what you're saying is that for you, your customers won't be interested in what Lou is doing, but your data center operators might be.
I hope that our customers will have no idea what he's doing,
okay,
and it will just happen.
So then maybe
as far as they're concerned.
Doug or Jack, to give Doug and Jack a chance.
The applications that are running on there might very well like that.
We'll probably have to rewrite our code completely, and our customers should
that's
be
the
able
question.
to tell.
Will you expose an API to your customers? Is there anything at the network layer that would be of interest to your customers? And Doug's been trying to jump in, and also Jack, since you guys are service providers that are operating networks and data centers, what is your perspective on that? Like, what's the reality?
All I would say is that for us to do that would move us more toward the direction of being an infrastructure as a service provider. Historically, we have not done that.
I think in our role as an infrastructure as a service provider, exposing those APIs to customers is critical. Our customers are looking more for infrastructure that they can leverage for their applications and have control of the network. I think one of the important things, getting back to network automation, to think about though is, there's a lot of new technologies with OpenStack and things like, or OpenFlow and technologies like that are doing software-defined networking kind of at the lower layer. But from a carrier perspective, we've actually been doing a lot of the things that are considered software-defined networking for quite a while. You know, we can't scale the networks to the ability that we have without having centralized configuration management, centralized database of all of our network policies and such. And we do all of our configuration modifications centrally today. Today, it's operators that affect a database and then push configurations out to all of the network devices. They still run the distributed protocols of the internet, but the policy changes are all centralized. So for us, what we're really looking at doing now is looking at ways to open those configuration management systems up through APIs to our customers so that they have the ability. But it's not a revolutionary technology for us. It's something that carriers have been doing for a long time.
Jack, do you have a
I
perspective?
think I was going to try to bring this all together to my two friends here on either side.
That'll be fun to watch.
As an operator, we have an interesting set of problems, and it feels funny to say, we've only been operating for a fraction of what many others have operated. But we always have to deal with a bit of legacy, no matter what, I don't care how old, whatever network you are out there, there's a bit of legacy or incumbency that you have to deal with. And when you think about just from an investment profile perspective, if you invest, even at the top end, 12-15% of revenue in capital a year, it takes you a long time to touch your investment asset base, the asset base. So we love things like OpenStack.
But it should not be a rip and replace, by no means.
Yeah, exactly. And so as we think about things like SDN, OpenStack, and all those, as the folks that work on these things think through, our biggest thing is how do we affect both the installed base as well as the portion that I will buy and build new each and every year. And that becomes a pretty important thing. We have $40 billion of assets. We want to be able to utilize all of those assets around the world with a new platform, a new piece of technology that touches all of that. And that becomes a pretty hard problem.
But even once you pass the installed base question, I guess to me there's two extremes that you can argue. And I don't think either extreme is crazy. One extreme is Peter's extreme, which is who cares about the underlying network? As long as it's there, as long as it works, it has the required performance around sufficient bandwidth, at sufficient latency, and so forth.
From the view of our customers.
From the view, you care about it, yeah, but I'm saying you don't intend to expose that to customers. You don't see them wanting to dabble.
Not what they buy from us.
At the other extreme, there's the view, which also has merit to it, which is we've got all this investment in network resources. And rather than just treating it as one big dumb pipe where you pour stuff in one end and it pours inexorably through to the other end, that you can do all kinds of clever things as far as pinning up virtual circuits and setting optimized routes and doing global control both from the integrated server load and network congestion perspective. So that's fundamentally two different approaches, and the question ultimately is from a vision perspective, right, excluding the fact that you've got an embedded base and migration costs to manage, et cetera, what's the right view? Like, is there customer value? Are customers saying, I want that fine-grained control, or are they all more in Peter's camp as customers of this kind of service say, yeah, whatever, that's great. So
I'll be a lawyer and say, it depends.
All right, fair enough.
We're a huge customer, one of Salesforce's largest customers. Our whole Salesforce uses.
Oddly enough, we're one of yours.
Yes, and so we absolutely believe in the utilizing the cloud, especially for our Salesforce, is just a great thing, and couldn't say enough great things about the company. But customers, not every customer wants to be able to dial in 12 different levels of QoS, but some do.
Yes.
And some want to be able to reconfigure how's my VPN work today.
And I actually think that's the biggest opportunity network services have to refine what they offer is in price for QoS at a level of granularity that's really not available for most providers.
I think that, and I think just information. Our customers just want to know more about their about their network. How is it performing? Give me more reports. Give me visibility. Doug mentioned, show me my trouble tickets, all of those things. I mean, basic information. When you think about how you interacted with a carrier 10, 20 years ago, you always had to pick up the phone. There wasn't anything you could do online. There wasn't any sort of reporting that you could get very easily. And I see some people laughing. I mean, in some ways, that still is how some operate. But providing that API, providing more visibility, I think is one of the keys.
If you look at what's happened on the computing side with virtualization, initially that was really the same IT processes, except you could load more applications on the same server and thereby get significant cost savings and everything else because you have higher utilization and efficiency. And networking is sort of lagged behind. But now we're approaching, well, what does it mean to have virtualized networking? And whereas initially, on the compute side, it was all about cost reduction and savings and everything else, it started now looking at much more elastic services, dynamically being able to flex the service up and down. And that's something I think that we can look for that, as guideposts. And now what's going to happen with networking? So that right now you have to over-provision all of these networks and everything else in order to get your peaks satisfied. Well, if we say that virtualization now will allow you to be much more dynamic on that,
Yeah, I think that's...
get the benefit of multi-tenancy and everything else. You then have a more efficient industry, lower costs, and you can address sort of the revenue challenges, I think, that people are looking at today.
I think you nailed it there, Lou. I think the question really is what happens in the future as we move from this kind of homogeneous, one-size-fits-all, best effort environment into a much more diverse set of requirements. And the bottom line is if you have this homogeneous view, then you get this lowest common denominator effect in terms of costing and pricing. So what happens is it's the least that determine the revenue that you get. Unless you have an ability to differentiate those services, it's very difficult to maximize the revenue from those services, bottom line. I think the key to solving that problem is exactly what we were discussing a bit earlier. It's modularity. It's about having the ability to modularize absolutely everything so that you can pick and choose which module you use for which function. And that modularity is not just for your internal business operations as a carrier. It's equally important for your customers. They need to be able to pick and choose. And being open so they can see the information that they need to make good decisions builds trust. So having a portal where you can go along and view how you're doing and make good decisions about where to invest and where maybe to reallocate resources just makes a lot of sense. It helps everyone in the whole value chain do better, and the whole value chain is going to benefit from this. And there's one final remark I'd like to make, and that is that the job that we have ultimately is as aggregators, all of us. If we're an equipment vendor and a software vendor, we're trying to do development that aggregates the needs of many, many of our customers. Likewise, a network operator is aggregating many, many services and so on down the line. And our job is to aggregate. We need to analyze the aggregate requirements across all those potential customers and make decisions about how to service those customers together as a set. And that's a little bit different than the idea that you empower everyone to control everything. Our job is still to control our own business and to provide those customers the best service they could possibly expect by hiding unnecessary detail through modularity, through service-oriented architecture. Exactly.
Well said.
Exactly.
I'll offer a qualification on that, which is that sometimes people don't want the best service they can possibly get. They want good enough. And Jack talked about the early days of the internet when people challenged whether something as clumsy as packet switched networks could even handle something like voice, which you obviously needed a circuit switch network to deliver with appropriate quality. Well, now you've got even people rediscovering that message in a bottle protocol called the datagram because they don't need the circuit level assurance that TCP adds to the IP network. If you've got a dishwasher that's updating you once an hour and you miss one of its hourly updates, it's probably not going to be.
Unless it's the update that says broken hose, but yes.
Yeah, I know. But
So
okay, fine.
we're at
So it's
that
updating
time
every
in
minute.
the agenda where
but
we can open it up for maybe
offering a
one
range
question.
of quality at a range of prices, an area where I think there's
Satisficing.
a large undiscovered opportunity where people think you always want more for what you're paying now. Sometimes people would be happy to get less for a lot less than they're paying.
As many providers have found that try to switch from free to fee, right? It's like,
Well,
so interesting. So do we
good
have any
point.
questions from the audience?
business
One right
model.
here, okay.
Yeah, I wanted to hear your views on the Internet of Things. It's clear that we've talked a lot about traditional networking
So,
Okay, exactly.
so in case that didn't get captured by video, the question is the Internet of Things and implications on network architecture or anything else.
My favorite phrase in this space is Jeff Immelt's at GE, where he talks about a world full of 1% problems. You've got any number of industries that have single-digit profitability margins like 5%. And if you can cut one of their core costs by only 1%, it's an enormous impact on their profitability. And when you can manage a field of wind turbines, not as a sum of individual devices, but because they're all communicating with each other, you can now start to do aggregate management across the whole field. There's one case on record where they've generated an extra $100 million in revenue from 2 wind turbine farm fields by being able to apply an Internet of Things discipline that manages them as a system of interacting entities. It's easy to get overwhelmed by the enormous percentages you hear in a Moore's Law world. There's a lot of profit to be gained by cutting some operating cost by just a few single digits, and an Internet of Things is very definitely a pathway to that.
So what about implications on network architecture? The traditional thing has been, rather than core out to the edge, it's edge back in.
You've got to start thinking about it as a system. If you are managing those dishwashers, or you're managing the next living room, which is the car that Peter's been working on,
It's not hub and spoke.
those become systems, and they therefore are managed at higher and higher levels of software, even though we're getting the information from smaller and smaller devices. And I think that has very profound impacts on networking. You obviously don't always need connectivity to those things. So as the number of things starts to dwarf the number of people that are connecting to the internet today, I think we're going to see some of the paradigm really shift around much more dynamic creation of these virtual overlay systems that have compute, storage, and networking, and they might only exist between 2 a.m. and 4 a.m. in the morning.
If you touch a hot stove, your finger jerks away before your brain even knows you've done it. That message didn't go all the way up and then come all the way back down. There was a near loop that took care of that.
Push to the edge.
So pushing appropriate levels of intelligence closer to the edge is going to be a change in architecture, and it's going
I
to take
think
advantage of all
the
of this.
traffic patterns on the network are going to change appreciably also. I mean, as Peter's saying, there's going to have to be more intelligence near the edge of the network, which is going to change the way we build networks and the way we do capacity planning in networks. You know,
Needs for security.
I was going to offer that. I jumped to being an engineer almost immediately in this question because, you know, I don't think there are huge implications in the core of the network as we think of cores and edges. And I don't really believe that there are. There are specific things, though. Address space, IPv6, absolutely a must. The way the DNS infrastructure works today won't work for. It will not work for the Internet of Things scale. Leveraging things like consumer devices. Consumer devices are not designed. When you go and buy your Linksys router or your whatever router for your home, it's not designed to talk to hundreds or thousands of things in your home. Spectrum management.
Cisco data furnace.
Spectrum management, the way spectrum's allocated for things like Wi-Fi and all the white space allocations and those things will become an incredibly important part of how do you have that many devices actually on the infrastructure? How does a radio antenna actually manage its power, and when does it send, and all those, there's lots of detail in there, but that stuff has to change.
So I'd like to add one thing to that list, which is when people think Internet of Things, I think they often think about things like sensors that are interacting intermittently, but there's the other Internet of Things, which is things like Ultra HD video cameras for safe cities that are doing 24/7 monitoring with immense bandwidth requirements, right? Where it's archived in the cloud.
Sure.
And that the cloud may include what some people have called the fog, which is not just a sort of remote data center, but something closer to the edge to be able to do some local storage and archival and maybe even image processing.
You have to have cameras that are smart enough that they only send signal when something's happening.
But that may or may not be deducible until after the fact, right, through tracking, let's say, because it may be, 8 hours later that this car blew up and you needed to have the background as to 6 hours earlier they went through the bridge.
But unchanging images of empty streets should not be being broadcast.
Not typically, exactly, right.
But I think the bottom line here is that we currently are human beings that consume most of the data that gets flowed around. That's the dominant consumer, whether you're watching over-the-top video or you're talking on the phone. Internet of Things to me means a much more diverse set of consumers of capacity, and not just capacity, compute and content. And diversity has its own challenges. It's much easier to design something that has one limited scope than to design something that has this broad scope. Basically anything anyone can imagine is in bounds. And I think that this is one of the profound challenges that the industry faces over the next several years. And it's also one of the best opportunities I've seen in my whole career. So I think all of us should expect a pretty interesting ride. The number one thing that gives me pause in this is that how do you solve that kind of diversity, that heterogeneity? And the answer is data centers. We have this ideal vehicle for dealing with and taming the challenges of scope and scale that lie ahead in this exciting time.
Okay, one other question before we wrap up.
Yeah,
Yes.
we heard a pretty good example yesterday of just pretty good performance from Alaska, where these native communities come into Anchorage, they see what their phone can do there, and then they go back and they start demanding, and they're going, please throttle us. But I guess to Peter's point about going back to the datagram, it's not obvious that would be cheaper, right, given the existing network. How big a shift would it be to reconfigure all the technical stuff that you guys do so that you could have that, we don't care if the dishwasher talked to us this hour structure? Is it a big change?
As far as I'm concerned, it's about building applications that degrade much more gracefully. One of my biggest problems with the word digital as an aspiration is that all too often digitizing something makes it more brittle, and I don't like that at all. The nice thing about analog is that if it's not working perfectly, you can still get something useful out of it, and badly designed digital systems, which is almost redundant, are notorious for they're either working or they're broken, and there's almost nothing in between. And I think there's tremendous opportunity to use some of the resources that the Moore's Law crank keeps grinding out for us to add resilience and add graceful degradation and add early warnings of sub-perfect behavior to systems, instead of just relentlessly trying to make them work perfectly, better, faster, and cheaper, but fail badly when they fail at all.
I think the internet has sort of proven the model, right? I mean, it's not a perfect system. It's
reliable.
I used to work for Vint, and he used to pound in my head that the notion that the reliability, end-to-end reliability, is not what the networking protocol is actually responsible for.
This morning? Because that was not an example of graceful degradation.
But I think it's proven that the business model that's come out of it has been proven that people are willing to pay something different for a different grade of service.
The good news in that also, though, is that when we talk about the opportunities and you talk about fog, and we are distributing intelligence over many different layers and ecosystems, which means, and they're all going to have computing. Computing is just cheap enough, you can put it everywhere. And so that creates new opportunities, I think, for differentiated services and everything else throughout the entire value chain. And so no longer are we going to be just beholden to, something that does at a centralized data center or whatever. A lot of that intelligence is going to be distributed out across many different layers here. That therefore, I have been talking to the carriers and everything. I keep saying, look at your data centers. Look at your data centers. Think about what you can do with computing and an adjunct and other services for your customers.
But if there's one thing that we can do, it's to take advantage of your APIs.
We need to start wrapping up. So
I'll
make this be, this is your closing comment.
This will be a closing comment.
Okay.
The one thing we'll be able to do is take advantage of the kind of APIs you guys are talking about. So instead of users needing to infer the state of the network from the behavior of their applications, applications can ask the network, how you doing?
Yep.
And applications can make appropriate decisions about what they'll try to accomplish given the network resources available. And that's the kind of thing that will hide imperfection more effectively from users and just make things seem much more intuitive.
So you do want to use loose stuff.
We do.
All right. Good.
Our applications
All right,
writers, writers will use your stuff to make it easier for our customers not to have to know about it.
Okay, so tweet length closing comments on either sort of pithy observations or maybe observations on the biggest misconceptions that you've heard of in this field.
Okay. I'm going to actually, what Jack said hit the nail right on the head.
I thought you were saying it was a misconception.
the internet has proven kind of the model that we're all going after. The cloud wouldn't exist if it wasn't for the internet. And I think that when people start talking about, changing underlying network protocols, realistically, we're going to be living in an IP world for the foreseeable future. We have protocols that we use today to manage that. We need to figure out more efficient ways to leverage the protocols we have rather than trying to replace what we have, which is one of the concerns I have when I hear people talk about software-defined networking as a new technology or a re-architecting of the underlying services of the network. I think that that's a kind of a dangerous path to go down because we do risk losing what we've built with the internet.
Okay.
And so
that was like 2 tweets, but
yeah, 2 tweets.
Good. Okay.
Sorry.
All right, Lou.
Keep it short. I think it's all about the apps and creating this two-way conversation between the apps and the underlying infrastructure.
What he said.
I'm not sure I have a tweet other than the whole notion of cloud and where the market and customers is going is, I think, because the cloud finally works.
All right.
Steve? Christmas Eve.
Yeah, I kind of think that it's really an exciting time because we can do things we couldn't have imagined just a few years ago. We've got to check some of our assumptions at the door, though, when we have these revolutions. I mean, everyone on this panel has had some experience in their lives where whatever was is no longer the thing that really mattered in terms of growth and the future. And I think a lot of good things enabling a lot of opportunity for all the carriers in this community, whether it's at the hardware level or at the software level or at the services and applications level. So it's just a good, exciting time for all of us.
Okay, well, some of this conversation will continue in South Pacific 1 at 2 p.m., where we'll have sort of a discussion around the cloud and communications and what it all means. So we'll either see you there or you can ask questions. Perhaps the panelists will stick around for another couple of minutes, but please join me in thanking them.